Okay, welcome again. I am still digging deeper into Python and RhinoScript, and then trying to take the RhinoScript over into Python nodes in Grasshopper. Now, I do want to say I got a little sidetracked yesterday for a multitude of reasons, but I got turned on to this fellow. I'm just going to pull him down here for a second. Right here, Jeremy Graham. Pretty fantastic, the videos he put out. This one specifically, I think it's like $49. I didn't get through it all, so I definitely want to get in there and learn how to script in Python nodes, making lots, handling surfaces, and all this stuff. Looks like I'm going to have to pay for it because I couldn't do it all in 24 hours. That said, which is a common thing, is I have gone back to the this tool, which is the primer, the RHINO Python primer by Daniel RUTTEN, and basically I'm just going through that 113-page document and writing some very simple scripts, and I'm jazzing them up with a little something extra so they look nice to look at. But as you can see here, I'm just rotating around a kind of simple function, and I've got it on emap. I'll take that off. I think I'll take it off emap if I can. Let me just go into analyze, surface, environmental map. Well, it's around here somewhere. I'll get it off if I can. Actually, what I'll do is I'll just take it and I will hide it. Now, if I hide it, there's probably something else there. Yeah, there's a little thing there as well. So I'll get rid of that guy too. I'll hide him. Basically, looking at this script, it started very simple. I went into Tools, Python script, Edit, and I wrote this script. Couldn't be much simpler. I think it produces like 81 points. Import Rhino syntax as RS, import math, and then can, I said can, RS enable draw false, and then call. That's what I have to do, call. And some of this information in RhinoScript I'm not really following. It's a comment. You know, you can read through the text to give you tons of examples, but the basic of it is for T in RhinoScript f range minus 50 to 50. They're going to have this. You're going to have the x, y, and the z of where they go. You're going to array those points, and you're doing a helix form in the positive and negative directions with this. So I'm using sine, cosine, which I love to use if you remember my other scripts as I was playing in Grasshopper. So I'm very much enjoying this, and I like putting all my operations into one node. This is definitely exciting for me. That it's better than the cluster, in my opinion, having all these Python nodes. And I'm making a habit of calling them my own now as I make them more and more useful. So that thing will run. I mean, like I could run that, and there you go. It just ran that point system up here. And of course, it's hard to see with Grasshopper on. And of course, I'm saying, where's my Grasshopper script? It's going to be underneath here. There it is. Let's just take all that off. And there you go. There's the points as they baked. That's what I like about RhinoScript. It kind of bakes it in. And it's getting into automation. So let's jump back in there again. Tools, Python script edit. It's just the fifth one out of the series. I'm only making the scripts like if they're tied to strings and numbers and they don't make sense to bring it into Python and into geometry. I'm not bothering with them. But you know, I'm halfway through the document now. I'm well in chapter 6. So you could change this. I mean, you could take that 5, put that 15 back down to 5, and you could sit and, you know, if you wanted one to be less high than the other one, you could run that script and you'll get this point. And it's kind of fun to watch it generate as it goes, slow and steady. I think it goes faster if I take out these comment lines, if I do that. And I'll just test that for a second. Not really 100%, but let's run that script. And expected token RS. Oh, that's because I called it. I don't know what's going to happen with this. Anyway, shows my ignorance. There it is. It just pops up too fast. So like if you can take this out, yeah, that's why that's there. So you can actually visualize and have a little fun watching things pop in and out of the script. So let's do that again, and we'll run it, and you'll see it kind of forms a nice little way of watching it because it's got like a weight on it or a timer or something. Anyway, that script, that's a lot of rambling for nothing. You should be able to copy a script, but then you want to bring it in, and this is why I do want to get into Jeremy Graham's full 5-hour tutorial series. I'm going to purchase it. It's going to show me how to do a lot better geometries, but all these ones I've been doing are pretty much the same every time. So I went in here, I grabbed the Python, I brought it in, I did make a list. and call it list A, put square brackets there. I went in here and I left in all the data the same. All I took was the Rhino script add point and gave it a title cool, and then I'm just appending the list A with cool, and then I'm running that to my output A. And that's it. And in doing so, I can, now it's generating this blue line. We can get rid of the one that I baked in from Rhino script, and there it is, kind of a nice form. And I can sit in here and I can play, but that's not the point of Grasshopper, as most people know. Let's just make it 10 and run that one. So it's going to cut off the bottom of it. Just updates as you go. I'll close that one. So what I did then was took this one, and let's preview off, and let's go down here and grab this one. And this one's much more exciting because now I've not only done that, I've also thought, what would it look like in polylines? What would it look like in NURBS curves? In interpolated curves, and what would it look like in NURBS curves? And I piped it so I could have a radius on it. So as we visualize that, all I've done in this script, and I'll pull this over because we're going to play with these sliders. I've labeled the sliders fairly simple. As we jump in here, oops. Grab that one, don't need that big. I've just grabbed the sliders and I've named them X, Y, Z, U, V because that's just what came in. So basically I can, if I want to make X go up, and I should probably put this on something interesting. Hang on a second, I squished that one over too far. Let's just put it in here. So there's our pipe form in orange. That's what we're going to play with. And I'll I grabbed it over to my other screen. It's always a pain in the butt trying to keep these screens happy. So here it is, the interpolated curve. So I went into here and I was like, I'll leave my list. I'll make that negative that goes down. I can play with that. And since I plugged it into X and Y and one goes to the negative, now I know enough about Grasshopper about I could put the node in here of negative, but you may as well just write it into your script. This is much simpler and much smaller and much more compact. You can also bring out this slider if you wanted to change it and have one that was higher than the other one. The Z you want to control as well, which is considering the amount of rotations that's happening on it. So I think I set it to 2, so it would be kind of like a 2 pi, but you can see some real fancy stuff happening. And as you move this around, the data, because of the equation, the trigonometry just goes wild. And it's just amazing to have this little cool script. Same that I could have drawn it out and written it in Grasshopper nodes, but I think scripting in Python is making more and more compact sense for me. And then the U and V, if I play with that separated, don't keep those uniform, that's just the multiplying factor of sine, the amplification of that. Now you're getting into some pretty cool forms. So you get into this and you're like, I guess I'll take that one to bake, and might take a second on artistic. No, there it is. Can't say I'd really make that form. I've modeled it. I might have extruded it in clay for something. I'll take this off so we can actually look at it. What a nice interpolated, crazy form. You've got your thickness. You could do like a poly. You could do like a variable pipe. Really have fun with this with the same data coming out of another Python node, or maybe even this one. But that's pretty cool stuff. There's a square one. It's going to take a second to run. There it is, going jing jang, and what a node! What a simple node with a. Once again, I'm going to take this script. I'm going to close it up, and I'm going to grab it again right here. I'm just going to grab, without all those nodes, actually I'll grab all those nodes. I'll just copy and paste it again, bring it down here, and I want to ungroup that. And we can ungroup this one. And I didn't mean to keep all that data. That data can shove back up here. Let's turn this one off. And this one's running as a polyline. We'll bring back in the curve, and I'm going on 8 minutes. I'm kind of rambling. There's a lot more to talk about, a lot more thinking of why I would do this, but this nice juicy form and how that's playing around and have a little bit with math. What was I going to do? Oh, I was basically going to say, let's take this. If we didn't care about having it slowed down, I'm going to take this off. I'm going to take this one off. I'm going to take this one down. And you could probably write Python more compact than this. So there you go. You got a 9-line code to test. Just amazing. Like little 9 lines of code. A few nodes added on to play with it and have some fun with it. I do like the NURBS curves the best instead of interpolating for some reason. And you've got pretty cool control, whatever you end up doing. And yeah, I think this is just the bomb. And you could just take these to clean up your script even more. You can interpolate. You could definitely write the interpolation and the piping into the script into the node. And you could give these some fancier names, so you know what's going on a little better. Anyway, 10 minutes, that's fun. I'm going to keep going through lists. We're getting into vectors, so I'm going to do some vector displays, which are always tricky in Grasshopper. If you got to make a visualization tool for that. It's points and vectors are very hard to distinguish when you're not, especially when you can't even visualize the one. But it's in the display tool, and we'll keep going. So hopefully you enjoyed that. Nothing too spectacular, nothing too fancy, but this act of just making a list or an array and bringing it out to a variable and then appending with that variable and then running it to A output. Doesn't take much to add 1, 2, modify 1, 3 lines of code, and modify 1 out of a 9-item, a 9-line script. Anyhow, thanks for watching.